colors and pulled dice out of cups. Sample 1 is cup number 1. 10 of them were white, 13 of them were colored. Sample 2, 10 of them were white, 39 of them were colored. And we are going to compare the difference in proportions between the two, and we had already pre-decided that we were going to do sample 1 minus sample 2. So, state, what do I need to do first? So, I did tell you that I get to choose whatever goes here. It can be a number, it can be a letter, it can be whatever. Do I have any reason other than doing 1 and 2 for this? Because cup 1 and cup 2. So, in this case, it actually makes sense here. If it is something that is context that makes sense, use the letter that makes sense so that you aren't having to go, well, what is 1? What does 1 relate to? What is that? Now to find the number for that. Make that easy on you. So we're going to write P1 is the proportion. What? Where? That. And I guess we had to decide this ahead of time, but we didn't really have to.
In cup 1 or in sample?
Sample 1 is cup 1. Does that make sense? Yeah. I should have written.
Oh wait, were they different cups?
Yeah. Okay. That one is 1. I separated them up. I'm going to forget. Because eventually we'll actually look at it. Just out of curiosity. Alright, so proportion of dice in cup 1 dot. Now technically I get a decision here because I didn't say this ahead of time, but what do I want to do? Just because that one's on top, we'll just go with that. I could have done that are colored. So then let P2, what's the only thing that's going to change? Cup 2 instead. Not kidding, I'm hot now. I'm not shake. Rolling dice first me out. Then what?
We want that to have the two different proportions.
So all I have to do now is literally write which one I subtract from the other. It's kind of hard for me to explain that that's all you need to do when I'm explaining it, but we just need to write. So I'm specifying everything that I'm doing. I'm taking my first cup minus my second cup portion. So we want to estimate the true difference in proportions, P1 minus P2, and then what? What comes next, even though I haven't talked about this yet? So I didn't specify this, but kind of relating, making connections along the way. If I don't give you something in last chapter, we by default go with what? And so 0.05 corresponds with a confidence interval being what? So we're just going to go with that. Alright, so plan, I'll start with what? Method. And this is a two sample Z interval for difference in proportions. One of those things that doesn't matter, but back and forth with the star while y'all writing. Why did I originally say that I used star?
To clarify that it's positive and negative.
both positive and negative, but then I kind of quit using it when
We're doing one tail.
we're doing tests because it could be one tail, two tail, it could be negative or positive, or it could be both. So I am choosing to write it again because we are back to
Having positive and negative.
intervals, which means we have positive and negative. I don't care ever if you write it or don't write it. I'm just explaining why I choose to now. So first condition, random. What would I write there?
That's beyond
Dice were drawn randomly,
Did you just say from both topics?
basically. Drawn, wait. So what can I say right here instead to make it easier on myself? So I can go ahead and put, like, if I'm the one stating it because I'm not reading from a problem, is there anything wrong with going ahead and saying randomly selected? No, and then I don't have to put it at the end. We're randomly selected from both, what? Cup 1 and cup 2. So you have to be explicit enough to directly reference each of them, but that doesn't always mean you need a lot of wording to do it. If you said both cups, I would count off because it gets to something like both groups, and you don't explicitly say which groups. So you do have to explicitly mention each one. And so again, I don't have to put parentheses randomly selected only because of that. I'm just writing it so that if anybody's watching the video later, technically I usually write this, but I don't need to because it's already written in there. What's next? Alright, so I actually write this one the way we started out with, N1, P hat 1, N1, 1 minus P hat 1, into P hat 2, into 1 minus P hat 2. So sometimes we are given these numbers, and sometimes we actually have to multiply to find them. For this problem, are we quote unquote given them, or do we have to find them? We're given them because when we're dealing with N and P hat, that means the number of successes from the sample, and not an N1 times a theoretical P naught. That's where I would have to do the math. So how many successes? Say that again.
Can you say that again?
Yes, I'm just thinking about the way I said. When we have to do this, we have to do math because this N of sample would theoretically have that.
Why don't we figure it out right now?
Because I actually counted the number of successes that were in this group. So this is for my sample and this is for my sample. So all this is the number of successes in the sample, which we had here. So I didn't have to do 23 times a fraction. Me saying that, if I hadn't said that, y'all wouldn't be messed up with that. I was just differentiating between. Okay, so how many successes did we have in sample 1? How many failures in sample 1? Next two numbers. And so I am totally fine with you just doing that, showing that each one of them are. Yeah.
So for random, if you were to randomly assign the dice to the cups, would we have to put that and selection?
There are some situations where it kind of can get funny like that, but like in real world, I'm gonna try to give you like AP for our curriculum. We try not to get to the point where we have to do it both. But we can. Okay, so my other class asked something about this. That was a good question. We never dealt with random assignment previous chapters because it wouldn't make sense. Because if I'm doing an experiment and I'm randomly assigning, I would definitely not be randomly assigning to how many groups? Just one. And that's all we dealt with so far. So now at this point, would it make sense to do an experiment where we only randomly assign to 2 different groups? So it could happen here where it wouldn't make sense to have happened before here. Alright, so there are at least 10 I have to be a little bit specific about individuals. What is the individuals here?
Dice.
Dice, I might even say dice selected. So dice selected is giving me like sample instead. And then so here, what would I define as my success? What would I define as population 1? And that's very explicit in what I'm doing and takes a whole lot less words, so I like that a whole lot better. Some of my answer keys, I think I've written it all the way out just to show you can do either one, but for the most part, they probably all look like that. And then, so what do I need?
So you can use one more application.
What's my last condition? Independent. Which is actually doing what? What was my N1? What was my lowercase n2? So I think some of my answer keys, I write it side by side like this instead of underneath. This is why I end up doing that more often, because eventually when I get here, I just take up less room when I write it left to right instead of up and down. So what is capital N1 talking about? What would capital N1 be? Now, if it were all the dice in there, do I have at least 230 dice in there? No. So this is kind of a weird one. Like, it makes sense that it's talking about dice in the cup, obviously. But how would I write it to make more sense? So I could select at least that many. So I can shorthand this a little bit and say, there are at least 230 times I could have done what? So now think about like wording it like an answer. Drawn a die from cup 1 and at least 490 times could have drawn a die from cup 2. And so now that you see what that's going to be like, I probably could have worded this a little bit different to have written less. I could have reworded this to say, I could have drawn a die at least 230 times from cup 1 and at least 430 times from cup 2. So once you kind of know where it's going, you can kind of reword it to make it shorter. Does that make sense? And that's why I was very vague with this one, is every single problem, you've just got to think through the wording. And some people are just going to write and not think about making it shorter, and some people are. Don't care.
Which part is that short?
like, because I'm saying, I say that twice, I could kind of put that at the beginning and say, I could have drawn a die at least 230 times from cup one and at least 490. So I don't shorthand it much, it's just a different way to write it. And I don't care how you choose to do that as long as you're saying that same thing. I do. What's first thing I need to write? P hat 1, which is what? What's P hat 2? Isn't that what, 49? What's N1? What's N2? And because of this, some people like to write P hat 1, N1, and then P hat 2, N2. I don't care. My confidence level is what? So we're dealing with a Z. A Z for 95% is what? That's one of those that's on your purple sheet book we've used a lot. Alright, so let's write our generic equation. Starts with what? Then what? Am I missing anything? This should be in N1 and N2. Probably what you told me. Now, at this point, if I handed exactly what is on the board right now to a 4th grader, 5th grader, then if I throw it back up. But if I throw it back up again, they could probably plug those numbers in, right? So, is it really necessary to write it again? So at the beginning, I have you writing it again to get used to it. But I have clearly indicated what every single thing in this equation is, and I have written an equation. But now, if you choose to go this route and not plug your numbers in, and let's say I forgot to write Z, then I'm going to get counted off for it because I didn't write down what it was to plug it in, even though I knew what it was and I used it correctly. Does that make sense? So if you have everything written down, you don't technically have to go to this next step. I'm just going to write it just because this is the first example. So then this would be 10 out of 23 minus 10 out of 49 plus minus 1.96 square root of 10 out of 23, 13 out of 23 over 23 plus 10 out of 49 times 39 out of 49 out of 49. So I am not going to count off if you do not write that line on your test if you correctly have everything labeled up here. But realize that if you do something like this and you miss, like if I forgot to put my N1 and N2 here, I'm now getting counted off for stuff that I did right. So that's up to you if you want to write it or not write it. So at this point, I do not see any reason ever taking the time to type all of that out by hand. The last couple chapters I said I'm going to show you how to use it in the calculator. You might use it, you might not. It doesn't really save you anything. At this point, it definitely does. So where am I going to go with my calculator? What button first? Stat. Where? Test. So again, I'm back here. My first 6 options say test, which is not where I am today. So I want to at least be down to intervals. Well, my interval options are all the way from 7 to B. I know I am dealing with a what today of these? I'm dealing with a proportion, which it says, and I'm dealing with 2 of them. So it's going to be B that I'm clicking on. And it gives me this list. So what is X when I'm dealing with proportions? Number of successes. So my X1 is going to be 10. My N1, 23. My X2, 10. My N2, 49. And I'm leaving my confidence level to be 0.95, which is where I set it. Stat tests. And it's all the way down to B. It's 2 proportion interval. 2 proportions the interval, yeah.
Okay.
And when I hit calculate, it is going to give me this. So it gives me my rounded estimate for p hat 1, gives me my rounded estimate for p hat 2. So if I wanted to write it that way instead of a fraction. And it also gives me my lower bound and my upper bound. So this gives me negative 0.0012. No, I want to write it the way I did it. Negative 0. Which is less than or equal to what? Which is less than or equal to 0.4626. If I am finding the difference in proportions, what would it mean if I get a negative number? That means the second one is bigger. So this side over here means there is a chance that the proportion of white in the second one is higher. This one, because it's positive, means proportion of white in the first one is higher. But this one's really close to 1 or 0, and this one's all the way up to about half. So it's somewhere between, basically, explaining this in context, it's somewhere between they're the same or the first one has twice as much. The proportion is half higher, 0.5 higher, 0.46 higher. All right, so let's go ahead and write our conclude, and then I'll actually look at the dice. So what do I start with? We are 95% confident. That what? What do I have to write? P1 minus P2. Then what? And I could write this as a decimal or a fraction if percent if I wanted to. I'm not going to with this one. if I had chosen P2 minus P1, what would my lower bound end up being? It would switch the order of these, and this one would be, so it'd switch the sign in the order, so it would be negative 0.4626 to positive 0.0012 if I had done it the other way around. X is your number of successes in that group. Yeah.
So did you not have the same amount of like colored and white dice in both cups?
I have no idea.
Okay.
But based off this, it's saying could they be the same?
Yeah.
Why?
Because
Because 0 falls in here. So we're not saying it can't happen, but based off this, it pretty much seems more likely that what?
cup 2 have more colored dice.
Cup 1 has more white dice. Okay, yeah, same thing. Cup 1 has more white dice, or cup 2 has more colored dice. Or higher percentage of, not more, because I don't know that the same number's in there.